normal distribution, like, you would have negative, can't have negative sales. So like, so normally when we transfer, when we're using GLM, like, we would use a link function to transform that, use a log link function. And therefore, like, it's the gamma distribution is most something you choose. And that's really good. And we have another group 4, Soso or Soso. Did I get your name right? I apologize if I pronounce your name wrong. So yeah, please. Sure. Binomial? Yeah, binomial you can try, but it's not common.
I'm just running an event.
So it's group 4.
Hello, Danny, are you still there?
Yeah, I can hear.
Oh, your reception is.
But you already mentioned. Oh, okay. Yeah. Right. I saw. Yeah, binomial. Yeah. Distribution. Yeah. So gamma distribution is like the most correct and the most common answer. But since Abra answered the question first, although like there's some the exponential distribution family includes Poisson or normal, but I think that's fine. Or we can call it even, like we give two groups 1.8. I think for group 1, like for binomial distribution, that's not correct. So I don't think you can use like binomial distribution for like stock sales. And yeah, so mainly because it's not a binomial distribution. Basically summarize the number of trials or observations, like when you want to predict the probability of a specific outcome.
Danny, I think your reception it's poor. Yeah.
Really bad. Okay.
The voice is breaking up. Yeah, I think we maybe should move on.
All right. If that's the case, hold on. Yeah.
Can we move on to the next questions?
Oh, I think what I do is I probably turn off the camera. Yeah, sure.
Okay.
Yeah. So I turn off my camera. Hopefully that's like give me a better reception. Question 2. Shall we use customer numbers as a predicting factor for the daily sales, and why? I think I partly answered this question, like in the earlier session. So it's like really a test of okay, well that's good. So A, yeah, group 4, yeah, please go ahead. Yeah, group 4 said A. Yeah, group 4, go ahead. Okay, so you're saying you can use customer numbers to predicting the daily sales within the model? Well, I guess yes and no. I think so you answer like, you say the number of sales correlates, like, well, the number of sales correlate with the number of customers in the store. But I guess in this scenario, like, I think because the number of sales is a direct outcome of the number of customers. And also, if you want to use number of customers as a factor within the model, you're gonna, like, run in some problems, because number one, like, if you want to use that as a categorical variable, you have to bin the number of customers, like, in the store. And number two is, like, if you want to use number of customers as a continuous variable to predict the number of the overall sales, and effectively that you're turning that how would I say, you're turning that model into predicting the average sale per customer, right? You sort of see what I mean? So I guess in that scenario, I guess the answer to this question would be you can't really using the number of customers as a direct predicting factor for the number of sales. Or if you do so, like, you may have a very funny sort of, like, model result. Group 3, you want to have a try? Abrin? Yeah, I think that's more, I guess, well, I don't want to say that's the right answer, but I guess, like, that's like, the approach that are worth trying. Now, I don't think as a predicting factor. I guess what I was referring to here is, like, when you guys attack, like, sort of tackling this kind of problem, rather than building one model, or, like, building one algorithm to predict the overall sales, you can break up the overall sales into two categories. So yeah, well, basically into two response variable. Like, you can break up the overall sales into, like, number of customer visiting the store. Like, that's one response variable you can predict. The second response variable you can predict is average spending per customer per visit. And then by, like, building two algorithms or building two models, I think you capture the distribution, you capture the behavior of both of these response variables, and then you can multiply them together to get the final sales outcome you try to predict. But as, like, again, this is how would I say, this is a very open question, and so how would I decide the winner? So yeah, group 3 and group 4, I think you both correct. Well, I think the number of customers, like, have a similar distribution with the well, like, I think, to be honest, like, I don't know that. I don't know, because I haven't really, like, looking at the data of the distribution. Maybe Robert can answer this question, like, better, if the like, the number of customers and like, the sales, overall sales have a similar distribution or exactly the same distribution. But I would guess, like, they highly correlated, and like, and I think but if you're only looking at distribution per se, like, you may get a similar, like, similar shape, yeah, but not exactly the same. Yeah, the shapes are similar, but not exactly the same. Yeah, thanks, Robert. Yeah, so I think that's what I mean. Like, say, so if they have the how would I say, a similar shape. So what are you trying to capture here? Like, if you're predicting the overall sales, you kind of like ignore the how would I say, the behavior of the average spending per customer, and the average spending per customer or per visit to each store could have different shape, or could have a different sort of seasonality. I think that's what I was trying to how would I say, alert you guys. So basically, when you're building the model, or when you're building any algorithm, you basically try to isolate the response variable you try to predict, rather than predicting the final outcome. If I want to use insurance example, as a direct comparison, the analogy, when we building models for general insurance companies, normally if we try to predict the the claim loss, we're normally predicting at least two outcomes. Number one is claim frequency, which means how many accidents the customer would incur, and the number two is we're predicting the severity, which is when the accident do occur, how bad the accident is, which means how much repair cost going to be, and then multiply that together would be your claim cost. So I think I would when I saw this problem here, at the store sales, if they got the number of customer information, and I would assume that this could be a sort of similar sort of approach when the two response variables, number of customers and average spending per customer, might be having a different behavior, or might be influenced by different factors. So hopefully, if you're breaking up into that two algorithm and multiply them together, you would have a slightly better model performance or prediction.
Okay. Sorry.
So yeah, after saying so much, I would yeah.
Sorry, I have to stop you there. So after discussing,
can I say both group 3 and group 4 wins?
Yeah. Okay. We'll keep a record. So after discussion with the event team, and we feel like
can we have two winners, or we have to only have one?
Normally we would only have one. The first team who answer the question correctly will get the mark. But the second one is welcome to try it. But if the first one is already correct, then the second team won't be rewarded. And also, each question we feel like student only have 3 minutes to answer it, and this is to avoid the.
Okay.
So if no one answers in 3 minutes, we have to move on.
Okay, that's cool. Sorry. Okay, that's cool.
Okay, question 3.
All right, if that's the case, I won't announce any winner here. I will leave the or teams to decide who wins that point. That's fine. So let's move on to question 3. This is open question. What extra data, what external data you could use. Okay, group 6. Yeah, lucky first. All right. What do you think?
Yeah, we can use macroeconomic data to predict the customer's behavior, like the GDP or the PMI, and that could affect the customer's behavior.
Yeah. That's very very correct. And I saw the chat group. I think group 6 answered first. So again, I think this is a very good answer. And I think if I want to add a couple more points, I think the other thing that we could use extra data. Normally in the Australia market, we normally go to the ABS. So they have this census data, census information, things like that. I think you could apply some similar in the Eurozone, if there are any sort of ABS or any statistic bureau that you could dig out more data. All right, this is very open question. So again, I leave to the organizers to decide who is the winner. Let's now move on to question 4. Question 4. Yeah, so this this is one like say why can't you just put all the factors in and just run the model, what could be problems of overfitting. Maybe this is too technical. All right, with trade-off between. Yeah, I think that's right. Group 5 answered the question right. Oh, okay. Like some factors may have no noise, some factors may have similar impact. Groups. Okay. Yeah. So in this one, I think group 5 answered the question first, but they didn't put an A. And then Abraham answered the question and put an A. So I leave to the organizers, and I think the answer is yeah, I think group 5 is right. It's it's definitely a trade-off, but it's a trade-off interpretability and also predictability. So basically, if you're fitting all the factors, you can get a perfect model fitting 100% correct with the historical data, but that's not useful for the predicting for future sales. So I think group 5 is that Danny, yeah, Danny, I think you're right. I think it's a trade-off between balancing you want to fit a perfect model, or you want to build a model which is very predicting for future sales. So yeah, let's move on to the last question. If you're thinking this question is too technical, wait until you see Robert's question. So I think you get a better chance in my questions now. Okay, so question 5, I think I went through this very briefly. What could be the what could be the some normal or usual data quality checks you can apply when you want to check the data quality? Oh, we got a here, group 3, right? Lovely. Group 3, yeah. Go ahead, group 3. Did you type A for this question 5? Oh, QQ plot. No. Yeah, QQ plot sounds cute. But not QQ plot. QQ plot is normally for when you're validating the model without, but not necessarily checking the data quality. Anyone else? I'll give you a hint, say, if, for example, you can check missing values, maybe something else you can check. Anyone want to give it a shot? Okay, group 3. Accuracy, relevancy. What do you mean accuracy and relevancy? Well, when you're checking the data, yeah. Group 4, give it a try. Oh shit! Yeah, we got group 6 then. Okay, group 4.
Yeah, I think maybe that we can.
I think after group 3 is group 4.
Yes, it came in from group 4. I think maybe we can have a check for the histogram for maybe numeric variable and for category variable that we can use a bar chart, is it, to check. And apart from that, maybe we can try to check whether they the numeric variable have the zero, I mean in zero value or not. If there is huge zero value, then we can separate the zero and non-zero value. And maybe that's it.
Yeah, yeah, okay, yeah, that's pretty good. So I think just to answer group 3's question, accuracy, relevancy. Yeah, well, accuracy, when you're checking the data quality, you can't check the accuracy, but it would be good if you have some data to reconcile with. But the data, another data set, you can reconcile the accuracy. So you can't say accuracy. Relevancy, I think that's loosely correct. And which you can see, if a factor is relevant. But I think the lady or the girl who answered the questions earlier on the phone, I think she got most of the points right. Yeah. So yeah, that's all the questions from my part. And I think again, thank you guys so much, and wish you guys the best of luck. And if you have any questions you want to follow up, just let the organizers know, and they're very nice. They I'm happy to answer any questions or follow up. Thank you, guys.
Thank you.
Thanks, Ron.
So the rest questions should be given by Robert, right? It's Robert here.
Yeah.
Question 6.
Okay, question 6. What is confusion matrix? I hope it doesn't give you too much confusion. Yeah. Maybe just give the answer. Okay, group 4, please. You can turn on your mic.
Yeah, can you hear me?
Yeah, okay, yeah, please.
So it's I don't know to explain it, but it deals with machine learning that is used for classification of data. Yeah, so that's the bit I can remember, I guess.
I would say it's partially correct. At least you have put it into the correct context. Yeah, it's a measure that is most relevant to classification problem. Yeah, and the idea of confusion matrix is. Do you want me to give the answer right away, or is any other team want to have a try? Predict the classification. Yeah.
It's used to know like
Yeah, that's it. Yeah, true positive, false positive. Yeah, that's it. Yeah.
Okay. So can we move on to the next one?
Next one. Yeah. Give 3 examples of accuracy metrics. Actually, in my demo, I have raised more than 3 examples. So yeah, if you have good memory, this is an easy one. Does anyone want to have a try? And you see, I'll see, recall. What is recall? Okay. There are just 2 examples, right? Can you come up with another one? Yeah. Okay, cool. Yeah, that's it. Yeah, correct. Next one. Next question. Is GLM summation or product? I mean, okay, cool. Yeah. Group 3 is faster. Yeah. Actually, no. It depends on how you interpret the result. If you take the exponential of your response variable, then GLM is a summation. But then if we just look at the response variable, it's a product. So, so no one gets the answer, I guess. Next one. This one is very difficult. Yeah, this one is very difficult. I guess we can give 2 marks if someone can answer this correctly. $10 seconds, and then I'll give you the answer. Okay, please, group 3.
I can maybe answer the intercept.
Okay.
So intercept is, I think, when the response equal to, when response equal to 0, what is the value for the predictor variable?
No, not exactly. Actually, you have to tackle this problem by taking these 2 concepts together. So what is intercept and what is one-hot encoding? And if intercept equals 2, meaning that we yes, please, group 5. Group 5. Yixuan, please.
Could you hear me?
Yeah, I can. Yeah.
So basically, one-hot encoding is either 1 or 0. So if we make instruction like if this store is open or not. So if it open, so type 1 is not open, so this becomes 0.
Yeah, and for example, we're only using one factor, and the factor has 2 levels, level 1 and level 2. And if we include intercept in our GLM model, do we use 1 level or 2 level as our rating factor?
Can I say it's too hard for me?
Yeah, okay, I'll give you the answer. Maybe I can share my screen. Can I share my screen?
Yeah.
Neither. John, can I share my screen?
Yep. So I'll stop share.
Okay. Okay, I'll share my screen. Okay, can you guys see my screen? I assume you can. Okay, so as I said, X has 2 levels, level 1 and level 2. If we use intercept and one-hot encoding, then we build a model like Y equals A plus B times X level 1. Like, okay, originally X is like 2 levels, level 1 and the level 2. Okay, by one-hot encoding, we just create a variable like X level 1 equals 1 when X equals level 1. Okay, but we don't create another variable like X level 2 equals 1 when X equals level 2, because this case is included in the intercept, like like A here. Okay, another way to do it is that we don't use any intercept, but then we have to include the other level. That's the difference. Okay, it's too hard, but I think it's relevant when you tackle your Kaggle project. So yeah, I just answer this question. Okay. So organizer, you can move to the next one.
Okay. Oh, by the way, who has the right question for question 9?
It's too hard, I think. Oh, sorry. That's one. Which one is more strict in terms of penalizing model complexity, AIC or VIC? Have you guys learned AIC and BIC in uni? Okay, group 3, please. BIC, yeah. Most of cases, BIC is more strict in terms of penalizing model complexity. Actually, you have to look at the formulas. If your data size n is big enough, then yeah, I would say yeah, you're right. Yeah, BIC is more strict. Yeah. Cool.
Okay. So just to confirm, no one has points from question 9, correct?
No. I designed the question too hard, sorry. Yeah.
Oh, hey guys. So I hope you guys enjoyed the session today. And it's great to see you guys get the competitive juice flowing. And I really like the way you interact with each other and network with our guest speakers and your fellow students. I think we should keep this up. It's really good for our for the project competitions. Okay, so up next we will have the Q&A sessions. I think Frank is going to take over. So I'll pass the microphone to Frank. He will answer questions from group 1 first, and then followed by 2, 3, 5. Okay. So Frank. Hello, Frank, are you here? Hello? Okay, so Q&A has, there's going to be 20 minutes for Q&A session, and for any students who wants to ask any questions, you are allowed to turn on your speakerphone. So for the guys who had previously had any questions on, I believe was Danny's part, you may ask them now. Okay. So by the way, Frank is a data scientist professional, and if you guys have any questions about a career shifting, or you're thinking about to transfer to data scientist, maybe you have any question like that, feel free to ask Frank. He's a specialist. Okay, so I see no one's speak so far. So yeah. So group one, Mel, would you like to ask any questions? Group one. Okay. Then let's move on to group two. Simon Chen. So actually, well, since since a lot of people have left, or I don't know, not listening. So any question you may have, just feel free to speak. You can type or you can turn on your microphone, whichever way you prefer. Hi, Frank. It looks like we have some students ask questions in the chat box. Abram asked the online course of ML or deep learning works.
Okay, I see. So I find someone is asking about if their online course of machine learning or deep learning hours to get for a job application. So I think it depends on what kind of what kind of job you would like to do. So and what kind of course. There are many machine learning related courses on Coursera. So yeah, I think it depends. So could you please give me more background about your question? Hello, can you hear me? Hello? Okay, so you are talking about, I think what you are talking about is the machine learning fundamental course from MQU, right? Okay, I think it depends on your background. So if you never learned such courses related to computer science or algorithms, I think it's a good I think it's a good start for you to get into this area. So, but if you want to do more deep research or more professional job in data science area, I think you should learn more. Yeah. Okay. The next question is from function. If someone would like to enter the data analytics industry, what skills are required? Okay. For the question from group 3, I think for me, the most important skill I will look at is how good is your understanding of the problem. Like, so I think maybe at the very beginning of the data analytics, you only need to do the analytics work. But later, if you want to be a very good data scientist, you should have the ability to do the work from end to end. So what does end to end mean is you need to get the questions from the real business scenario at first, to identify the problems at first, then use the proper model or proper methodology to solve the problem, then present it to your stakeholders and to prove it's valid and efficient. So I think this is the most important thing. Secondly, by having these kind of abilities, you should have a very solid domain knowledge in that industry at first. I think I'm not a data-driven guy, so I think for me the domain knowledge is quite important. You need to know what industry are you working at. Secondly, you should have a very good understanding of the algorithm or methodology. So it means you need so you should be able to understand the details of the formulas and the pros and cons of these models, and maybe you can you have the ability to modify the model to do some advanced work. I think last but not least is the presentation. It is the last stage, but it is the most important stage. That how you can present your result to your stakeholders. Yeah. So that's all for the required skills for this industry. The next question is, so your major is Michelle from group 6 from Michelle. So your major is accounting, but I want to do jobs like something combined with accounting and data analysis. Do you think? As I don't have a accounting background, so I'm not sure about so what kind of job could be. But as far as I know, maybe some business intelligence work is suited for you, but it's more it is more focused on the presentation or the business insights issues, like you do some basic analytics on data, then present, then do a campaign or a business insights. I think something like this, but I'm sorry, I'm not a professional specialist in accounting, so not quite sure about this. So what type of certificate or skills would assist us to get a better job on business analytics industry? So I think so this question is from group 4, Jun. So I think as I mentioned just now, so I think their business analytics is based on the industry. So it's quite hard to say a general certificate or skills would assist you to get a better job. But I think if you want to do a finance job, maybe FRM is a very good certificate for you, but it's especially for the risk management or quantitative risk management area. Okay, the next question is from Ian. What is better for a beginner, R or Python, if I want to do business analysis in the future? Okay. Yeah, okay. I think yeah, I met similar questions many times before. So someone's would like to get an answer from which one is better. But I think for me, there is no language is the best in the world. So there's only the language that suits for your job. So I think for me, I prefer Python better at this stage, but I used to do R more. So I think from my understanding, the difference between the R and Python is, so firstly, they are both of R and Python are script. So it's not like not a high level language like C or even Java. So both of them are scripts or MATLAB as well. So the difference between R and Python is, so R is very popular in the statistics area, especially in the research area. So there are many statisticians developed many fancy and very popular libraries on R. But the problem is, if you want to do those advanced models, you need to be very familiar with that models and then read the original paper from the reference. Otherwise, you will get a very unstable parameter estimation result, or get abort or errors very often, as it's all free and not very stable. But the statistical models are very powerful. Python is a little different. So it's from the data science area, not from the statistical area. So I think for Python, it's more, for the fundamental libraries, it's more stable. And the parameters for those models are more simple and brief. It's easier for you to, I think it's easier for you to use those libraries as a beginner if you're not very familiar with those advanced statistical models. Yeah, so that's my opinion. But from the syntax side, I think there's not too much difference. Yeah, so just some details. Okay, the next question is from group 4 K-Man. Can we use SPSS to produce graph, give support in competition report? Okay, I think this has been answered. Okay, as you mentioned, presentation to stakeholders. It's very important. What is the most important information need to be included or need to be delivered? Like, okay, that's a very good question. So as I discussed in the WeChat group with organizers, I think several days ago, within the report, I think you should have a very good structure. Not only from your presentation, but also in your report. So in business, the model, we don't do model or do the result for research. We do for real business scenarios. So the first thing in the presentation or the report is you need to identify the problems and then show your understanding of the report. then have a very brief conclusion of the whole work you did. So like a very good summary at first, like the abstract in the paper. Then you should be very familiar with the listeners or the stakeholders of your presentation. So it depends on different scenarios. Like the presentation is for the group members of your team. They're all technician guys. So I think your presentation should include many technical details, to explain why you choose this model, and what are other candidate models, what are the pros and cons for all these candidates, then why you choose the final one. Then show the metrics, the results of your work. Then last, do a brief summary about the limitations and restrictions of your work. So that is for your group members. But if it is for your boss, I think you don't need to do don't need to present too many details of the technical or methodology part. So, but if it is for the C levels or for board, I think that it's more. It will be simplified. Just the background, the problems, and the result. So I think that's the. So I hope that answers your question. So it depends on different business scenarios. Okay, how to improve the ability of doing projects end to end before graduation? Okay. To be honest, I'm not quite sure about this. Maybe do some part-time work. So the next question is from Danny Wu. Can you give us any thoughts about transition from business data analyst to a data scientist? Any suggestions? So I think for this question, it assumes you are already a business or data analyst, right? Like from a junior position to a senior position. I think, yeah, maybe the most important thing is have a very deep understanding of this industry, of your area. As I mentioned, domain knowledge is quite important. Yeah, if you have a very good domain knowledge, you can then you can understand the problems from the business. The next is from Group 4 Cayman. Which programming language is more popular for data scientists in the industry? Of course, Python. Yeah. Of course, Python, yeah. So R may be more popular for statisticians. Okay, so I think I answered all the questions right. Hello?
Yeah, hello.
So do you have more? Do you have more questions?
I think that's all the time we have for this.
Okay.
Thanks very much, Frank. Thank you.
No worries.
Okay, let me share my screen. Here's a little summary of the the results we got from the quick quiz sessions. And well done, guys. I hope we had fun from that, and the little bonus mark can also help you for your final projects. But for the groups who didn't get marks, that's okay. Also, don't give up. Here it's a little preview of our next event, which is a feedback of data analysis competition. We will announce the winners. And little spoiler alert, the winner will be rewarded with $200 for cash. And second and third teams will receive a certificate. First, second, and third will be rewarded with a certificate that basically saying you participate in our project and receive the first and second titles respectively. Okay, cool. For these competitions, we have 6 weeks to complete. Well, we have a detailed marking criteria, which is sent to you via email. So check your emails. Okay, looks like. So for this competition, we want everybody to have fun while competing. Really, we just want to see your maximum efforts. So it's all right if you don't win. Hopefully, after this, you will have fun and also learn something new, and also meet somebody, meet more people. Cool. So the stuff we talked about today in this workshop, that was an example, which is very similar to the actual project dataset. By the way, this session is fully recorded and will be uploaded to YouTube, our AWS channel. So the links will also be sent to you by email, so just stay tuned. Here is our contact info. You can reach us on WeChat, email, LinkedIn, Facebook, Instagram. You can take a screenshot of this for future reference. So if you have any questions, don't hesitate to contact us. Okay, and special thanks to our other branches, and all of your contributions to this event is much appreciated. So thank you. Okay, then that's the end of this workshop, and thank you so much for attending. And hopefully we see you in our third workshop. So guys, thank you very much. Have a good one. See ya.